Hello everyone, today in this video we are going to make an IoT controlled car using the Blynk application as the interfacing app and using the NodeMCU and using the L298N motor driver module. So let's get started. So now let's understand the circuit diagram. This is the L298N motor driver module and this is the NodeMCU. So D8 pin of the NodeMCU is connected to IN4 of the IN4 of the motor driver module. D7 is connected to IN3, D6 is connected to IN2 and D5 is connected to IN1 of the motor driver module. EN1 is connected to D1 of the NodeMCU and EN2 of the motor driver module is connected to D2 pin of the NodeMCU. So for this motor driver, working of this motor driver, we have supplied it with 5 volts. It has built-in regulator, and through using this regulator we have powered this NodeMCU. Next, the motors are connected in the parallel connection of the each side. So this 8th pin, this out 1 and out 2 is connected to the one side, that is first and second motor, which are also connected in parallel combination of the motors, and this 3 and 4 out 3 and out 4 is connected to the other set of the motors, and the ground of the NodeMCU is of course connected to this ground of the motor driver module. So this was about the circuit diagram. Let's see how can we configure the Blynk cloud. So first you have to go to the Blynk cloud and make an account, log in, and this window will appear. So firstly we are going to create a new template. We are going to name it selecting hardware as ESP8266, connection type as Wi-Fi. Then we are going to make data streams. So we are going to select virtual pin. So we are going to make data streams according to the motion of our robot or car. So for the forward motion we are going to use the V0 and minimum as 0 and maximum as 1. We are going to select the data type as integer. Similarly, we are going to create the data streams for respective motions. So now we have created the data streams. We will click the save and then we will just go into add device. From the template, choose the template as car control and create. So you can see we have successfully added our device here, product, and you can find this Blynk authentication code right here on the top right corner. So this code we are going to require in the later part of the video, specifically in the code section. So this is how you can configure the Blynk cloud for this project. Now let's configure the Blynk Android application. So here you can see we have our template here. So we are going to set up the dashboard. We are going to select buttons, forward, backward, left and right. And then So you can see we have arranged it according to the motions forward. So this is backward, left and right, and this is the slider for the speed control. So we'll select the data stream as forward for the forward motion. Then for the right motion, we are going to select the data stream as right. Similarly, we will do it for the left. And finally for the backward motion. And then for the speed control slider. So we'll just enable the show value option. Now we have successfully created the interface using the Blynk app. So now let's understand the code section of our project. So firstly, I'm including the two libraries, ESP8266 Wi-Fi library and this Blynk simple library. So this library is used to connect our NodeMCU to Wi-Fi network. Blynk library is used to perform various Blynk application functionality. So I am storing the value of Blynk authentication code which we have got from the website into this variable, and the Wi-Fi SSID into this variable, and the password into pass variable. Next I am declaring the output pins which will be going to the motor driver IC. So 14 pin is the D5 pin of the NodeMCU. Similarly 12th, 13th, 15th, 5 and 4th pin are the respective pin of the NodeMCU. Next, in the void setup, I am initializing the serial monitor with a baud rate of 9600. Then I am initializing the cloud server of the Blynk using the .begin function which is built into the Blynk library. So I am passing here AUTH, SSID, pass and the address of the cloud as arguments in this function. Next I am setting the pin modes of NodeMCU to output. Next, in the void loop, I am using the .run function which takes care of data actions and which is also responsible for keeping the connection alive. Next, I am using the Blynk write function in order to make the bot move forward, backward, left and right. So for the forward motion, when we will make the value of V0 as high from the Blynk Android application, this F variable will also become high. So this will store the value high because of this command here. Next, I am just using the digital write in order to send the command to the motor driver module. So by default the value of F is low. So when the all pins of the motor driver module will be low, it will create a break condition. That means the car will not move in any direction, it will be at rest. So when the value of F is 1, the value of in 2 and in 4 pins on the motor driver IC will be also high. So this will create a condition that will move our car in the forward motion. Similarly for the backward motion, when the value of B is high, the NodeMCU will make the value of in 1 pin and in 3 pin of the driver IC to the high position. This will create a condition that will move our car in the backward direction. So when for the left motion, when we will press the V2 button on the Blynk Android application, it will make the value of L as high, and this will also set the value of in 1 pin and in 4 pin of the motor driver module as high. This will create a condition that will move the car in the left motion. Similarly is for this right motion. So last function is used for the speed control. So whatever the value we will set from the slider ranges from 0 to 255, it will be stored into this SP variable using this command. And I'm just using the analog write function in order to write the values into this EN and ENB pin of the motor driver module. So this was about our code. Now it is time for testing our project. So here you can see this is the IoT control car and this is the Blynk interface right here. So this interface has 4 buttons, as we know: forward, backward, left and right, and the additional speed control dial. So we can control the speed of the car from here. So now let's make the speed as 0. So you can see no matter how much I press these buttons, the car is not moving. So let's move the speed to its full position. Now you can see how much responsive is the car. So this was about our project. I hope you have liked it. Thank you very much.